Past few days we have talked about how to name and write formulas for different types of compounds. We are now going to focus in on how to actually draw those molecules so you're able to see what's happening to the electrons and who's bonding with who and what a molecule looks like. For covalent, we're simply going to use the electron dot diagrams that we talked about at the beginning of this unit and circle the electrons showing how they are being shared between each atom. Remember, the electron dot diagram shows the number of valence electrons, which correspond to the group number. In a covalent bond, you have three types. You have a single covalent bond, a double covalent bond, and a triple covalent bond. They pretty much correlate with the number of electrons that are being shared between two atoms. So a single covalent bond shares one pair of electrons. So for example, here you have two hydrogens, each one sharing an electron. That is a single covalent bond. Now, something that you need to add to your notes that was recently added to the curriculum is that since it's only sharing one pair of electrons, it's going to have a weak strength, or it's going to have the weakest strength. And since there's hardly any strength with that single covalent bond, it's going to have the longest length between the two atoms. So the length between these two hydrogens in the actual molecule is going to be longer for a single covalent bond. Now, the next thing you've got to be able to do is actually draw those bonds and show how they are actually sharing. So F2 means you have two fluorines. So we're going to draw F and F, two fluorines. Now we're going to draw the dots that go along with the fluorines. Fluorine is in group 17, so therefore has 7 valence electrons. This one as well. Now remember, at the beginning of this unit we talked about the octet rule. Pretty much it states that atoms form compounds in order to fulfill the octet rule. So the octet rule in most cases means that they want 8, because most of the noble gases have 8 valence electrons. So right now fluorine has 7. To fulfill the octet rule, it's going to share with the other fluorine. So now these two electrons that I just circled, one from this fluorine and one from this, these two electrons are being shared between these two fluorines. So this fluorine now has 1, 2, 3, 4, 5, 6, 7, 8. It has fulfilled the octet rule. If you count the other fluorine, you get the same results. So they have a single covalent bond. Everybody's happy and good to go. NH3. N, typically the element that's in front of the compound goes in the middle. So nitrogen's going to go in the middle, surrounded by 3 hydrogens. Now hydrogen, if it was in front, if it was H3N written that way, hydrogen never goes in the middle. It can't go in the middle because hydrogen only has 1 valence electron. So there's no point in putting it in the middle since it only has one thing to share. So hydrogen never goes in the middle. Carbon always goes in the middle. Okay? Other than that, whatever's in front goes in the middle. So the hydrogens all have 1. Nitrogen's in group 15, so it has 5. Now we're going to share just like we did here, so everybody fulfills their octet rule. So hydrogen has 1, it shares. Hydrogen now has 2. Does that fulfill the octet for hydrogen? Yes, because hydrogen's happy with just 2. Energy level 1 only has, or can only hold 2 valence electrons. So once energy level 1 is filled, hydrogen is happy. So hydrogen and helium are happy with just 2. So then we go to the next hydrogen. It's good to go. Next hydrogen, good to go. Now always go back to that center atom and make sure that it's fulfilled the octet rule as well. So nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Did it fulfill the octet rule? Yes. Now another thing that we need to talk about are these 2 electrons here. In a different color, I would box those in because you need to know what they're called. These electrons on the center atom only are called unshared pairs. They are the electrons on the center atom that are not being shared with any other element. We will be counting them later, so you need to make sure you know the name of that. Should be fairly easy to know that name, though. Okay, so next, we have a double covalent bond. The double comes from the fact that they're sharing 2 pairs of electrons. So 2 atoms are sharing 2 pairs of electrons. So what do you think if we're adding another pair of electrons in there? What happens to the strength and the length of the bond? It's going to be medium strength, and it's going to be medium length. Since that strength went up a little bit, it's going to cause the length to shorten as well. Example, oxygen gas, the air that you were breathing, the gas that you're breathing into your lungs, this is what the molecule looks like, O2. So O, 2 oxygens. Each one, oxygen comes from group 16, so both have 6 valence electrons. Now, we need to take those 6 valence electrons and have somehow oxygen end up with 8. So to do this, oxygen shares a pair with the other oxygen. Now the most common mistake for students to do is just to link them up and move on. But again, you're trying to have everybody fulfill the octet rule. If you just circle one pair like that, you are not complete. Because oxygen now has 1, 2, 3, 4, 5, 6, 7. It's not there yet. It's still unstable, so it's not happy. So therefore, you're going to show that it shares another pair simply by circling 2 more electrons. So now oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And you can tell that this is a double covalent bond because of those 2 circles between the oxygen. Triple covalent bond. 2 atoms share 3 pairs of electrons. So what happens to the strength and the length? It has the strongest strength. Okay, the more electrons it's sharing between the 2 atoms, the stronger the strength. Therefore, it's going to have the shortest length. It's pulling those atoms closer together. So, N2 makes up 79% of the air around us. N2 means 2 nitrogens. Each one has 5. Circle. 1, 2, 3, 4, 5, 6. Is it stable? No. Share another pair. It now has 7, still not stable. Now it has 8. 1, 2, 3, 4, 5, 6, 7, 8. Once you have everything sharing like it should, you're done. Now, we're going to take what we just learned, and those are called electron dot diagrams or Lewis structures. Now we're going to make structural formulas, which it just means you're going to take the same drawings you just did, and instead of having circles, we're going to turn them into dashes. Okay, so just some examples here. This is water. This is sulfuric acid and ammonia. Okay. So we already drew these in the notes. So if you need to refer back to the notes for this, you can. So when we drew NH3, we had N in the middle, surrounded by 3 hydrogens. What type of bond did we have between N and H? Single, double, or triple? We only had 1 pair of electrons shared between this N and this H. Therefore, that's going to be a single line. Same thing here and here. Now, the only other thing that this needs in order to be correct is there any unshared pairs that were left on the center atom. That's the only atom I care about leftover dots. So if you go back, I had a little box around some dots up here. Those are your unshared pairs. You need to include those in your final drawing. And that one is complete. We have the circles that have turned into dashes. We have leftover dots on our center atom. For F2, we have fluorine. Again, only one shared pair between, so we're only going to put one line. Since there's technically no center atom, we don't need to worry about leftover dots. N2. How many pairs of electrons did we have circled between these two? We had 3. So therefore, when you draw the structural formula, you need to have 3 lines between the 2 nitrogens. Again, no center atom. Don't worry about leftover dots. Now, exceptions to the octet. We've already talked about 2 exceptions. Hydrogen and helium only want 2. BF3. Let's draw this. Boron goes in the middle, surrounded by 3 fluorines. All the fluorines have 7. Boron is in group 13, so it only has 3. Fluorine has 7. It needs 1 more, so it's going to share 1 more pair. Again, same thing here and here. If you count all the fluorines, they all now have 1, 2, 3, 4, 5, 6, 7, 8. Fluorine is good. Now, back when we did NH3, I told you to check the middle atom. Make sure it is stable as well. So boron has 1, 2, 3, 4, 5, 6. Is it stable? In most cases, your answer should be no. But boron only has 3 valence electrons to begin with, so it cannot really expect to have 8 since it can't share any more than 3. So therefore, you need to know that boron is stable with just 6 valence electrons. Then you have some greedy ones. Phosphorus and sulfur can expand their octets to having 10 or even 12 valence electrons. Now, the next thing's going to happen is we're going to have to take these drawings and figure out the actual shape of the molecule. That will be the next video.